Bueno, buenos días.
Good morning, I'm Berta. I'm part of the development team in GeneXus, and that's a presentation. Well, now, I'm telling you that we are working on the next version. I'm here to talk about modules. We started talking about modules a few years ago, when they showed us the icons of these three fabulous worlds and the things we imagined for the future, including films and all that. I'm a fan. I love films, and I thought of one in particular with these dark and green images, because the program had three presentations with the word reloaded in their names. So this brought me back to the film, and I will quote these characters. In Evolution 3, we presented modules 1.0, and now I'm going to show you what the next version will be, the 2.0. That's why we have this reloaded version. My presentation has four parts: an introduction of Evolution 3 today, the KB component scenario. For those of you who follow us, you will understand what this is and which case we are facing with 2.0 modules, all the cases that are being studied, and then the projection for the Salto version. As I said, the modules exist already. They are an important feature in Evolution 3, which are very disruptive in terms of KB. And our idea is to decide what to solve with that particular version. The main objective was to understand the knowledge base better. A recurring issue, something that we saw and discussed with several customers, was how difficult it was for a new person to face a project with GeneXus when they had to start working with a solution that was big enough and all the objects appear. The solution we found was to create modules. And we incorporated a new object, which is the module object. If you're not familiarized with these objects, you may wonder. If you're trying to categorize, you had other things. But a module is not just the creation of an object to organize objects in the knowledge base. A module is a feature that has an impact on all objects. Now, transactions, web panels, procedures have a new property, which is object visibility. And you can use that to say whether the object that belongs to a module can be called from another module. Can it interact with other modules or not? And this allows us to do something. Each module defines an interface. I know which functionality the module is exposing, how to interact with it. And to complete this scenario of understanding, or better understanding, we have a diagram that shows us how modules interact with each other and see what objects of a module can be called or communicate with objects from another module. Our customers, and I see many friends here in the room, they have large KBs of knowledge, KBs, and they are precursors, and they have followed this feature for a long time. They still have many themes that we were not able to face, and this is what we want to do now. And they tell us about these things. And for example, they tell us that when they work in GeneXus development, they have to work with the whole KB. Even though I may have chosen one specific functionality, but I have the whole KB. And those KBs that are very large, with over 10,000 objects, the number of objects has a strong impact on the performance of development with GeneXus. The main point here, the burning issue, is F5, or the more objects we have, the longer time we need to estimate. The calls are longer, and that is a problem. Also, duplicate objects in KBs. What do I mean by this? Many times, if you have different projects, you know that there are functionalities common to those objects. You develop functionalities, and then you duplicate or copy in other objects. In general, I have a procedure, I generate the XPZ and use it in several KBs. It would be great to avoid duplicity. If I have to make a change in a version, I will have to replicate in all the other KBs. And the last point that I want to mention is intellectual property. How can I expose certain functionalities without, by maintaining the way I did it? I provide it, but how it was done should not be public. To solve or to try or to deal with these issues, we think of a scenario for the component KB. We will start by dividing this case into 3 types, depending on its complexity. The simplest one is the API integration. If you are part of this event, I've heard it over and over again. The basic idea behind it is that we have companies that expose their data. We have many functionalities that have been solved in the cloud, and many times we want to integrate with this information that is appearing as public in the cloud. These 2 cases, Mercado Libre and Parse, are well known by the development team because we have developed solutions for them during the work of the team. In the case of Parse, if you did not attend the presentation of the Mexican League talk, this is a component that is used by the Mexican League, and it helps it send notifications. They say that during a Mexican soccer championship, they could send 1,000 notifications per second, or more than that. And this solution in the cloud allows them to solve that problem of sending notifications. If there is a goal, the fans of a team will get a notification about the goal, and it will reach them through its telephone or device almost instantaneously. The idea behind it is for these 2 components, both integration with Mercado Libre and with Parse, appeared as a need to solve on a given KB. But this could be exposed or shared so that somebody else could use it. These are small functionalities, and here we may talk about API integration, API integration. The solution by Parse is 12 procedures. It's very easy to generate an XPZ and somebody else consume it. But if we add up APIs that we want to integrate, the number of objects we add to the KB increases. So how can we facilitate these integrations? Here things get more difficult because GeneXus has a main object which is transaction, and we have defined data for that. GAM comes from GeneXus GX Manager that solves the security aspect. But the characteristic of GAM is that it exposes functionality, and when you integrate it in your KB, apart from functionality, it requires a data store, a defined data store. And the peculiarity is that it will not impact my knowledge base and the structure of data it requires or generates. And the third case is the more complex one that requires, you have to think more about it, is the ERP. Basically, when we have a shared database. There was a presentation on this, the case of ERP of K2B. They are using modules. They have a large solution to use modules, and then they have to integrate each module to provide a final solution to their client. And the peculiarity here is that they have to take steps to share this KB. To sum up, what is the scenario we want to solve? We have two KBs. One is exposing functionality, maybe the resolution of an API, the case of GAM. We have screens, maybe we want to share, or the case of events that is used by ERP to personalize implementation. Now, this KB wants to provide a functionality, and we call it component KB. And we will have a client KB, that's the one that wants to consume the functionality. This is not new. Many of you may say, this is what I do. Now, the thing is, it's not easy to integrate the two KBs. So, what do we want to do with modules 2.0? How can we approach the problems I mentioned? By having this integration helping me to avoid bringing objects for me to create the other KB. When you activate GAM, to use it, you don't get 600 objects that integrate GAM. They don't come to your KB, and that's the idea. We want to use the binary, the compiled code that we already have, that we already generate. So how can we reuse this code we already have? It's very easy to do it from the other KB. The solution is to evolve, to use an automated system to facilitate the integration of compiled code with a GeneXus KB. So the first thing we need to do, if I take the case of API integration, the code is already compiled. How do I facilitate the incorporation of that code that I generated in a new KB? We need to define an interface to do so. The interface of the component KB exposes the functionality, and we must have a mechanism in the client KB to consume it. And this is where the modules play an important role. The modules have already defined a defined interface, which functionalities they will use, what objects they will use, and from that definition that I have, I generate an interface and consume it from the client KB. What do I want to do with this? I want the client KB. I will have to define. I will look at the objects. They are public in the module, but I don't want them to generate anything. Today, a mechanism that will help me do this, if you want to consume and generate an optimal object, you can communicate directly with the binary. If there is an internal object and you create it, there will be a change. And how can you avoid these things? As we were thinking about issues when we want to integrate two KBs, one problem is duplicated object names. I did not mention this before, but when you use a module, there are objects that derive from other modules. I may have, for example, two procedures with the same name in different modules. But in evolution 3, we have objects that are global. The attributes, the dominions, the sub-themes, some objects are still global in the KBs. If I'm developing a solution that I want to share, when I'm developing a solution, maybe I'm not thinking about sharing it. I just develop a solution. I need my user table. I generate the user table with the names of attributes. And then I realize that this can be encapsulated or distributed. And maybe I'm going to cause conflict in your solutions because you will have a user table as well. So what we do in this case is we want every object in the KB to have a module. And then we are able to solve this problem when we don't need to worry when I expose functionality whether there will be a conflict with other objects that have the same names. We already had the qualified names, and the change now when we use modules is that we don't have type name as an identifier of the object in the K-base. The module is part of the global name of the object. And now we want to use it for attributes so all objects in the KB will have a module. With these two previous cases, these two topics, we think we are solving the scenario of integration with API. It would be easy to generate the binary and the databases and all that. But if we make things more complicated and we think of GAM, the main point is that I have a structure, a database, and these structures modify and evolve over time. So I will have to work with versions. And we all know that as data evolve, we generate reorganizations and we cause an impact if we want to consume them on the other end. So we would like to make them automatic and have them automated. So the the component KB generate a reorganization, and as they evolve and there is a second reorganization, we need something that helps us go from one version to another. And the client KB requires a mechanism so that we can apply the reorganizations in the right order. And this is the main idea for us to attack the GAM case. What about DB referential integrity when we are already sharing the database? We will have to define restrictions, have considerations as to the operations we will execute. We're always thinking about automated procedures, improving procedures, what to do, what not to do. In this case, the component KB shows a user table, and the main idea is for the client KB. This is the main restriction. It will not be able to modify that structure, but it will be able to define referential integrity. So we are in the process of specifying the steps we need so that when we need to apply reorganization, we need a mechanism to really temporarily remove these defined temporary references, execute the procedure, and at the end of the process, use the referential integrity again so that our knowledge base is defined as it was before. So what's going to happen with the binaries that we are talking about, the binaries we are generating, and the KB will work with different versions? We may have many different versions. So here a new component comes up. This is something we need to develop, and this is GeneXus Module Manager. The idea behind the GeneXus Module Manager, this is based on the package managers that like NuGet, and there are some peculiarities here. Each of our versions of interface may appear on different platforms. In addition, platforms with DMS. Thinking about GAM today, how do we generate it, how do we distribute it? In the setup of GeneXus, there are 6 implementations of binaries, and there are combinations with platforms for Arubis, .NET, MySQL, and SQL Server. Who's going to manage that diversity of versions? We would like GeneXus Module Manager to do that. The component KB will expose the binaries to this new member, and the client KB will request options. They're telling me I'm running short of time. Client KB will have to see which options to incorporate in my knowledge base and whether it is available for the platform that I have defined. I wanted to show you what we are currently doing so that we can go right into the conceptualization of these changes.
Sí, está en duplicate. Creo que no. Ahí está. Tengo rápidamente.
I'll show you quickly. I have a KB, and this is what the connection is doing with IMDb. That's a site for films. I defined a module for connection. I have objects in italics. These are private objects. I can look at the interface definition for the module, and I have only public objects. I will add public. I will have a mechanism to publish this interface. I'll say it's 1.4. I'm trying different things here. And now I have to generate the binaries. In this case, I will generate one DLL. I put the interface. I'm exposing the interface. This is compiled here. And it's ready. I exposed my functionality. Then I have another KB. Very simple. I want to consume, or GeneXus module management shows me which packages I have, which versions they stand on. And this is going to import the interface. And here a node appears. This is bringing references. And here you see that the objects that appear are public objects that I defined in the other interface. I can start using this to define a variable. And have one call to the object. This is the one. Search by type. If I look at the objects I imported, they have certain peculiarities. I only get the information I require to communicate to that object. I don't see the source. I don't see all the rules. I only see the pan to make the call. I look at the variables defined because I use them. And the structures that I need. In the case of results, this is the structure itself that I need to use. Now I have integrated the calls. I do not make a difference as to whether the object, as to where the object is. Is it in my KB or is it compiled from an external module? And I'm using that module because I'm integrating to it. When I say view, it looks for the film and it shows me this, and I'm integrated. So very quickly, that was my demo. So we start working on the scenario of API integration, and this helps us define and solve in the prototype stage how to integrate with a knowledge base quickly. So, during the event, I heard the issue of the cloud mentioned over and over again. And they asked us recently, what are we going to put up in the cloud? We would like to integrate these binaries that I am copying locally. Do I really need to copy them locally, or could I use this module as a service? We would like to work in cloud implementation, so that when I generate the binaries, they are not locally located. They should go to the cloud. So I need to generate an interface so that the client KB consumes this, and this can be integrated with the GeneXus model manager. And this will tell me whether I have to generate a REST call because the binaries are in the cloud, or whether I need to update or bring the DLL to incorporate it to a local project. And what can we expect of Salto? I mentioned the main topics that we want to deal with to solve the problems we saw in the beginning. So let's attack these two problems, GAM case and API integration. I want to define the interface and know how to consume it, define duplicity of names, attack even the attributes, so that even attributes have names, have modules, I mean. And this deals with GeneXus core. When we decided to use modules, we changed from the ID to generators. The impact is very strong. It's not something that's very visible that the end user sees, but we have to modify normalization algorithms to support this feature. And in the case of ERP, this is the case where we currently need more work to be done. We need more analysis to be conducted. Lots of people have come to us raising problems. We need to work a little bit more to see how to solve this issue of sharing the database. We have defined some restrictions. We know we cannot modify the table that is defined by the component KB, and maybe there are other issues. So we've been collecting information to consolidate a solution. If you're not using modules, all these functionalities will go in the module. So the first recommendation to you in Evolution 3 is to start using modules, start defining the interface of each module, define their interfaces, and on top of that, we will evolve. The prototype that I showed you is simply a prototype. It's not included in the Salto version or in the beta process at present. It is a prototype and we are evaluating it. It's an internal activity. We are validating the ideas. So these changes are huge changes, so we don't want to break the beta process of other features. But as we complement basic functionalities, we will start moving on and you will be able to test these things. Thank you then for coming this morning. This is what we are thinking about. Salto will be ready by mid next year, and we'll keep on working on these issues. Thank you for your attention.